from 2007 onwards, odds are you'll need DDR3 memory. Anything before that, probably DDR2, and apparently Anthony was born in the year like 2000 because he clearly doesn't remember that there was DDR1 and SDRAM before that. But the point is, if you look up the model number, you'll be okay. Now, if you have a very new system with an X99 motherboard, or really anything that comes out after us filming this video that also supports DDR4, then you'll need DDR4. But for most folks out there with a reasonably modern system, but not like super hyper bleeding edge, DDR3, and you're good to go. Now, what about the differences between speeds? Can I mix and match them? Yes and no. It will technically work, but you can run into compatibility issues and crashes. We recommend you stick with the same model of memory whenever possible. As you get into larger capacities, like even up to 8 gig or 16 gig sticks, the problems get worse and worse with mismatched memories, because being on the bleeding edge means sometimes compatibility takes a little bit of a nosedive. Ideally, you'd like to get all of your memory at the same speed grade as well. I mean, it doesn't make a huge difference in terms of performance what speed you run your memory at, but if you use multiple sticks of memory at lower speeds, then your motherboard will automatically run at the lowest common speed available. So here we have some DDR3 1600 memory and some 1333. So even though there's some 1600 sticks in there, it'll perform at the same speed of the 1333 megahertz kit. So what about brands? Well, on a certain level, memory is memory. If you have two kits with the same specifications from two different manufacturers, then their performance will be pretty well the same. So you pick a brand based on warranty, design, reliability, or your experiences in the past, and prices, of course. You can't really go wrong with big names like Corsair, G-Skill, or HyperX. In fact, let us know in the comments below which brand is your favorite. One thing to watch out for, though, is that sometimes, aside from the primary timings, the sub-timings, when set automatically, can be handled differently from one brand or another brand or one stick to another stick. So again, can't say this enough. For the best possible experience, you should have the same brand with the same model, and even bought at the same time, because they'll actually revise them from time to time for like perfection. Next, what about two small sticks versus one larger stick? I was kind of joking before, because if you want 8 gigs of RAM, traditionally people recommend two sticks of 4 gigs instead of one stick of 8 gigs in order to take advantage of dual channel speeds, which is an effective doubling of bandwidth. Now, if you're using an integrated graphics solution like an AMD APU system, then yes, a dual channel kit will dramatically improve your gaming performance. But for others with dedicated graphics cards, the real life benefits of dual channel is not that noticeable. Now, if you're already buying, high capacity sticks, then yeah, get 2 of them in order to get the right amount of memory for your system. However, if you're just buying one stick with the intention of upgrading it later, just buy one high capacity stick instead of 2 lower capacity ones, because then you'll have more room to expand in the future as you discover yourself needing 16 or even 32 gigs of memory. And I'm dating this video a little bit because I'm sure that's just going to be the norm by the time a lot of you are watching it. So another common question we get is, hey, my friend just upgraded his system and has an extra stick of memory. Can I add it into like my system? Well, if you're not using an AMD APU system or onboard graphics, then the answer is yes. The performance gained from the additional RAM can often outweigh the negatives of running in single channel mode, but a good way to know whether it will is check out your task manager. Find out if you're actually running out of RAM or not, because memory will not affect the performance of your system unless you have a need for the additional capacity. I hope that covers all the questions you had about upgrading your RAM. If you have any more, leave a comment down below or shoot an email to the PC advisors at NCIX, pc@ncix.com, who offer free, non-commission advice for your system upgrades or your new system. Thanks for watching, guys. Be sure to like and subscribe for more videos like this from NCIX. Memory. Memories, me and you go on and on. One of the most common questions we get around here, especially when a new graphics card launches, is, hey, Linus, or hey, Keys. Oh, you shouldn't ask him, though. Actually, he helped write this script, so maybe he knows more than you guys think. How much graphics memory do I need? Well, that is a very good question. I mean, Nvidia and AMD just launched new versions of their top-tier graphics cards with 8 gigs on the AMD side on board, like 8 gigs of RAM. So who are those actually for? Why would one need double the amount of VRAM that was previously offered? We'll have the answer for you right after these messages.
Club 3D's MST Hub can run 3 monitors off 1 DisplayPort. No daisy chaining required. Click now to learn more.
And we're back! Before we go any further with this topic, I guess let's start at the beginning. What the heck is VRAM? Well, it's a specialized version of dynamic random access memory, or DRAM. Similar to the way your normal system RAM keeps the CPU fed with data, the VRAM keeps your GPU, or your graphics processing unit, fed with the information.
Hey guys, it's Bang from about PC Gaming. Someone asked me earlier to do a comparison between 16 GB and 32 GB. So, considering I've got loads of time since the bank holiday, I thought I'll give it a go. So what I'm going to do is test 3 games that I know to use quite a lot of system memory. These games are Rise of the Tomb Raider, Ark Survival Evolved, and The Witcher 3 The Wild Hunt. After that, I'll also be doing a quick rendering test with Adobe Premiere. As I would expect, there will be a difference as you can allocate more memory and depending on how much you've got to the task. So here's a quick look at my system with 16 gigabytes of memory. And here's a look at my system with 32 gigabytes of memory installed. Okay guys, looking at a 16 gigabyte system setup, I'm using an Intel i7 5968 running at 4.6 GHz. Memory is using 16 gigabytes of 156 MHz auto event Intel DX DDR4, and I'm also using 1200 MHz and 1950 MHz. And the GTX 980 Ti, also using Windows 10 Professional.
Gather tribute and earn my favor. Gather tribute or face my curse. The choice is simple.
My life returns.
gigabytes of memory available and 3 gigabytes reserved for other applications. So I'll go ahead and give myself a 5-second start and see what kind of time there is between 16 and 32 gigabytes of RAM.
Sequences augmented.
I grow tired of your petty squabbling. Gather tribute. Earn my favor.
Okay guys, that's the end of the comparison. As you can see, there is a 23-second difference. In favour of the 32-bit system. So for someone who renders very large projects, you will see a slight advantage, not a massive one, but there is a small difference. Obviously when it comes to gaming, there's no difference at all. Currently, there's no game really uses more than 16 gigabytes of memory. So that's pretty much it guys. Hopefully you guys have enjoyed the video, and as always, thanks for watching.
Hello again, I am Blunty, and this system right here is an ultra-compact little sort of low-end steam machine kind of clone that we built here on the channel. It's been through a couple of different bodies already. This latest incarnation I'm calling Little Anvil because it's small and it's incredibly dense. And if you want to see the build log of, you know, this tiny little case and squeezing a full gaming rig into this ridiculously small volume, just 11.5 litres. There's a link to the video on the screen and also in the down below area. But today I want to talk about the way memory affects gaming on a system like this, where there are choke points. There's the, you know, a low-end CPU and the low-end graphics card in the GTX 950 and an i3. And when I was first building this system, HyperX were very kind enough to actually supply the memory for the build. Now, originally I had planned to put 4 gigabytes in here because that's what the low-end Steam machine that I was kind of cloning had, the Alienware sort of i3, the lowest end anyway, 4 gigs memory, i3. I was going to do that, but when it came time for the build, the HyperX people didn't actually have the memory that I intended to use, and they sent me a 16 gigabyte kit instead of slightly faster memory. And I went, fine, like I'm going to say no to that. More memory, faster memory, excellent. And a little while after the build, I actually did wind up sending me the original, slower 4 gig memory that I intended to put in there to be a more representative Steam machine. So what we're going to do today is put it through its paces. We're going to look at the 4 gigabyte slow memory, or slower memory, and the 16 gigabyte faster memory to see how much of a difference it actually makes in real world gameplay terms when you're dealing with a budget minded system like this one here. So let's get to it.
I ran my testing with a few different AAA titles: Tomb Raider, GTA 5, Just Cause 3, Star Wars Battlefront, and Rise of the Tomb Raider. All are being tested at 1080p with settings recommended by the GeForce Experience. We'll start with the oldest game first, the Tomb Raider reboot from 2013. Minimum system requirements want just 1 gigabyte for this game, and recommended system requirements call for 4 gigabytes. So on the face of it, any difference we see here should be down to just the speed difference of the memory itself. And in the benchmark, max FPS remains identical actually. However, on the slower memory, it does dip lower by about 6 frames per second, 42 FPS compared to 48. To some, that will be a noticeable difference. And during actual real-world gameplay, it's not a difference that seems to rear its head in any obvious way to me.
In either configuration, the game remains smooth and playable and enjoyable. And if you built two identical systems side by side next to each other, one with the 4 gig, one with 16 gig, and made me play these games side by side, I don't think I could tell you which one had which memory. Now, in Rise of the Tomb Raider, just a couple of months old now, minimum specs call for 6 gigabytes of RAM. Recommended says 8. Rather annoyingly, the sequel didn't see fit to have a proper benchmark built in. So, just real-world gameplay here. And perhaps in later, more texture-heavy portions of the game, the 4GB being below the 6GB minimum would be an issue, but at least in the opening acts of the game, there's no appreciable difference. Seriously, you guys, though, I have to find time to actually play through this game properly so I can use the later, more complicated levels for my benchmarks. But for the purposes of these demonstrations, this does just fine. Now, the much more sophisticated and scientific testing from the clever buggers at Digital Foundry, which you may have heard of, have indeed shown that on low-end systems where I3 CPU maxing out is a bottleneck, memory speed can indeed make an appreciable difference in frame rate. It's a very interesting bit of testing. But when a game is set up properly, so ideally the CPU does not max out and create a bottleneck in the first place, it seems the minor difference in memory clock speed that I'm testing with here doesn't have a chance to make a noticeable impact. I mean, sure, it's there if you go looking for it, but as you're playing the game, you'd never know. However, in the next few games I tested, it shows that beyond clock speed, the amount of memory makes a huge difference. And in fact, it was a much bigger difference than I had anticipated. Star Wars Battlefront, for example. This game wants 8 gigabytes as a minimum, so with the system toting just half that, how do things play out? Well, surprisingly, the game actually runs nicely-ish. Almost a match for the larger amount of faster RAM. Except, at irregular intervals, you'll see massive dives in frame rate. The game basically hitches completely as the RAM is maxed out and everything in the pipeline has to wait on it being cleared so everything can catch up to itself. Now, the on-screen frame rate counter isn't quite keeping up with this phenomenon, but you may be able to see it for yourself, and you can certainly absolutely perceive the difference in how the game feels to play with these little hitches and stutters. It is significant. In fact, it borders on unplayable. Even though, as you can see, the frame rate mostly pings up into the fast 15 and triple-digit range. In Just Cause 3, which just like Battlefront wants 8 gigabytes as a minimum, interestingly, that 8 gigabytes minimum is also the recommended figure. But unlike Battlefront, the larger open world and its complex physics engine make 4 gigabytes of RAM utterly bulletproof and beyond playability. Which again, considering it's half what the game asked for, is no great shock or revelation. Frankly, Battlefront working as well as it did with this much memory is the far more interesting result. But yeah, obviously unplayable, so let's move on. Grand Theft Auto 5, I think, was the most popular game on Steam last year, and the results here are very interesting. Unlike Just Cause 3 and Star Wars, its minimum specs claim 4 gigabytes of RAM is just fine. However, as you can see, having more memory makes a monumental difference to the game while sharing identical settings and identical hardware in all other respects. Just like Just Cause 3, a complex physics-driven open world means pushing a lot of textures and other information in and out of memory constantly. And while the nippier 16GB in the i3 rig setup has no issues at all, in fact it runs the game quite nicely, if you starve it of RAM, even while giving it the 4GB minimum at once, the game actually becomes catastrophically unplayable now. Now the settings I'm using do run the GTX 950's own comparatively modest 2GB of VRAM to the ragged edge, in fact deliberately bleeding over that ragged edge, and there are a fistful more things I could turn down to give the system some more breathing room, but as you can see here in this gameplay from the 4GB setup with a more VRAM friendly batch of settings, the game still falls below what I would consider playable, and what's more, not only is everything turned all the way down, I'm running it at 720p. And there it is, the whole point here was to show the difference the RAM can make. And in this case, it's not so much the speed as it is the amount. Now, none of this is new information, it's one of those things I've always wanted to try and see with my own eyes exactly how drastic the difference is. You can read all day long in forum posts and things about self-proclaimed experts saying this or that about memory and memory speed and amount of memory, all that kind of stuff, but until you do it for yourself, or at least see someone do it in a real-world practical setup like I have here, then they just work, don't they? And while I expected the results in the Just Cause 3 and Battlefront tests because they explicitly want 8 gigabytes minimum, which GTA 5, which flat out claims 4 gigabytes, will get you by, on this system, even with literally every last graphical option turned down and diving from 1080p to 720p, nothing was enough to get it to a playable state. Only changing the RAM, giving it a breathing room of 16 gigabytes of RAM, not only does it run smooth, but it runs smooth at 1080p, and it runs smooth at 1080p with several of the options turned up to high, and while redlining the VRAM on the GTX 950. So, the long and the short of it is this. In any future system that I build, I'll be overbuilding on RAM. In my main rig that I built about 7 months ago, Devil's Crevice, I chose 8 gigabytes of RAM because that's what's widely accepted to be just fine for games. It is at, or above, the recommended specs for pretty much any modern and current AAA title. And in that system I also run a GTX 980 Ti and the top-end overclockable Devil's Canyon i5. So clearly there's not nearly as much bottlenecking potential there as there is in Little Anvil here, with its deliberately low-end budget-friendly specs of an i3 and a GTX 950. But it's very clear from these tests that overbuilding on memory is a relatively inexpensive way to build in an extra bit of future-proofing and kick potential performance up several notches. You can see for yourself, plentiful memory can make a vast difference to game performance under certain circumstances. It's the difference between being utterly unplayable under any condition and smooth and playing the play with a bunch of settings on high. So that you've seen the evidence for yourself. Now it's your turn to tell me what you're going to do in your next build, or are you going to upgrade the memory in your current build? Because obviously it makes a difference, and like I said, it was a far bigger difference than I ever expected. I mean, I knew, you know, more memory and faster memory is going to make, at least on paper, a pretty radical difference. And I thought in the real world, we'd see that and it would sort of have some impact. At least I was hoping it was going to have some impact, because otherwise we're always spending way too much on components, can't we? But as it turns out, they're not spending too much on components. In fact, we could probably stand to spend a little bit extra, particularly when it comes to the memory when we're building a system, particularly if you're building on a budget low-end system. You're trying to squeeze out every last drop of performance that you possibly can from the system, trying to keep it, you know, as inexpensive as possible. And as it turns out, more memory is a super good way to do that. So there you go. Please do the thing in my down below area to make me happy. That's the worst one yet. Thanks for watching. I am Blunty. We'll catch you next time. I hope this has been as interesting for you as it has been for me, because for me it was really interesting.
Well, you guys asked for it. At least that's how I interpreted all the likes on that video I did recently, where I asked you to hit the like button if you wanted to see these puppies. So here it is, one of only a handful in existence. Corsair's Dominator Platinum 128 gigabyte DDR4 2400 megahertz RAM kit. And let's try that whole thing again. Drop a like on this one if you want us to make a video showing you what's in this ultra-wide Heroes box that I just got in the mail from LG. The Corsair HX 1200i power supply delivers 80+ platinum efficiency for quiet performance and Corsair Link Digital Advanced Monitoring and Control. Click now to learn more. We don't do videos about memory kits very often these days, so when we do, we like to make them count. So instead of just doing a bunch of sexy unboxing footage where I tell you guys about how your memory kit with its customizable and color-changeable light bars and sexy heat spreader design, should you wish to spend this much on it, will come in a custom box that was specially made for 8 DIMM sets and includes 2 matched trays of quad-channel DDR4 memory running at 2400 megahertz with Dominator airflow coolers to go on each side of your motherboard for maximum cooling and sex appeal. Instead of doing that, I'll find something interesting to investigate and bring you guys along for the ride. So not that long ago, we determined that even for a high-performance quad-core processor, DDR3 versus DDR4 didn't impact performance much in desktop applications. But I want to take it further this time and find out if we need quad-channel DDR4 RAM, if we kick things up a notch and throw an 18-core 36-thread processor at the same multi-threaded benchmarks. So I fired this baby up on my usual Asus X99 Deluxe test bench. I was only able to get the RAM running at 2133 megahertz, by the way, but I know that my Xeon has trouble with high-speed memory, and when I tried it on a 5960X, it worked fine, and that shouldn't affect our test results much anyway. And then I ran my suite of benchmarks with 128 gigabytes of RAM in the system. Then I was all geared up to slowly ramp it down and run it in triple channel, and then dual channel, and then single channel, when I realized I'm really not expecting this to make any difference anyway, so let's just drop her straight down to 16 gigs of memory, which amazingly is one single stick of this RAM, and then see how the benchmarks go. And as expected, going from single all the way to quad channel makes pretty much no difference in anything but our 7-zip compression benchmark and synthetic memory bandwidth tests. And in those cases, we were nowhere near filling up all 128 gigabytes of our memory either. Which leads us to the conclusion already. Who and what is this RAM for? Well, it's for people who want the ultimate bragging rights to make their EP bigger regardless of the cost. And I guess there is something brag-worthy about having literally the same amount of RAM as your buddy has storage space on his boot SSD, even if it will be years before desktop workloads benefit from this kind of a config, and anyone running that many virtual machines or any of the simulation or rendering workloads that can benefit from this much memory should probably be using ECC registered DIMMs in a server or workstation anyway. It's just that this is a lot sexier. Speaking of sexy, Squarespace. Build a simple, powerful, and beautiful, aka sexy, website with 24/7 support, a bunch of different templates, whether you want to make a store, a blog, or a portfolio, or whatever the case may be, and with prices starting at only $8 a month, with a free domain thrown in for the first year if you sign up for an entire year of the service. They feature responsive design, so your website looks great on a PC or even all the way down to a phone. And they've got cover pages, a feature that allows you to set up a beautiful one-page online presence in minutes. You can start a trial today with no credit card required and start building your website. Just head over to squarespace.com. And I think it's /Linus, but whatever, there's a link there, and use offer code Linus to get 10% off your first purchase. So that's pretty much it, guys. Thanks for watching, and I have a new outro script that hasn't started rolling up the prompter yet. Right. If this video sucked, you guys know what to do, but if it was awesome, get subscribed.